Hello, and welcome to this very brief presentation on the precedent rules. You may have heard of the mnemonic BODMAS, often stated in mathematical textbooks, and that relates to the sequence in which we should undertake calculations. This presentation considers numerical calculations such as the one shown here, 3 squared plus 10 multiplied by in brackets 8 plus 4 divided by 2, then subtract the 12, and considers the order in which we have to undertake that calculation to comply with the precedent rules. There is a separate presentation relating to the use of precedent rules, or BODMAS, associated with the use of algebraic expressions and equations. Precedent rules. The order of precedent of an arithmetic or an algebraic expression can be referenced through the mnemonic BODMAS. It's defined in table 1 below. The mnemonic BODMAS is simply a framework which allows us to structure our calculations. So in the BODMAS mnemonic, the first precedent or the highest precedent is to consider any brackets that are present within the calculation. So brackets is the first precedent. The second precedent relates to what are termed operations. Often they're indices, raising numbers to powers or rooting numbers. But operations also encompass sine and cos type functions. So the O is for operations. The third precedent is to undertake any division of numbers that are present within your calculation. So third precedent is division. The fourth precedent requires us to undertake any multiplication that might be present within our calculation, so the M is for multiplication. The fifth precedent is the addition of any numbers within our calculation, so the A is for addition. And finally, the sixth precedent is to undertake any subtraction that might be within our calculation, so the S is for subtraction. So that is the rigid structure that BODMAS is trying to instill in us when we undertake our calculations. We should note that BODMAS relates to general calculations involving numbers or fractions, but it also relates to algebraic expressions and equations where we have symbols present such as x or y. Example 1. We're asked to evaluate the following arithmetic expression. 3 squared plus 10 multiplied by in brackets 8 plus 4 divided by 2, and then we're subtracting 12. So from our precedent rules using BODMAS mnemonic, the first thing we have to consider are brackets. Do we have any brackets in our expression? Yes, we do. We have the 8 plus 4 in the bracket here. So 8 plus 4 gives us 12. So there's the 12 in this line. The next precedent is operations. Do we have any operations? Operations being things like squared, cubes, that kind of thing. And yes, we have a squared term here. We have 3 squared, so that becomes 9. Next precedent is division. Is there any division to undertake within our calculation? Yes, there is. We have the 12 divided by 2. 12 divided by 2 is 6. Next we have multiplication to undertake. Is there any multiplication in our calculation? Yes, there is. We have the positive 10 multiplied by the 6 here. So 10 times 6 is 60. The next precedent is addition. Is there any addition to undertake within our calculation? Yes, there is. We have the 9 added to the 60 here, so that's where the 69 comes from. And then finally we have subtraction. Do we have any subtraction to undertake? Yes, we do. The 69 subtract the 12 here will give us the 57. So that shows you the rigid nature of BODMAS and how to apply it to undertake a calculation. However, we can simplify the BODMAS mnemonic slightly, because in actual fact multiplication can be undertaken before division, and subtraction can be undertaken before addition. So sometimes the precedent rules are more simply stated in a pyramid format, as shown in figure 2 here. So within the pyramid structure for the precedent rules, the first priority is still brackets. If we have brackets in the calculation, we must consider them first of all. Our second priority is still operations, any squares, square roots, sines, cos, etc. We consider them next. But our third priority could be either undertaking division or multiplication, because they actually have the same precedent. So we could do multiplication before division if that was more convenient to us within the calculation. And finally, the fourth priority is addition or subtraction. Again, if we wanted to, we could undertake a subtraction before an addition if that is preferable. So I personally prefer the precedent rules shown in the pyramid structure as shown in figure 2. Just very briefly, returning to example 1. It's just for a moment we go back to this part of the calculation. We have positive 10 multiplied by 12 divided by 2. Following BODMAS rigidly, we would undertake division first, so we would have the 12 divided by 2 here, which gives us 6, and then we'd multiply the 10 by the 6 to produce the 60. However, we could have multiplied, first of all, we could have multiplied the 10 by 12 to produce 120, and then divided 120 by 2, and we would have still ended up with the 60 value. So as you can see, we can do multiplication before division, and it doesn't affect the overall result. Similarly, considering this part of the calculation, we undertook addition first, so the 9 added to the 60 produced 69, and then we subtracted 12 to produce the 57. However, we could have subtracted the 12 from the 60 first of all to produce 48, and then add the 9 to produce 57. So again, you can see we get the same answer even though we undertook the subtraction before the addition. That's just for general reference. Here are some arithmetic essentials. This is just a recap of something you already know. When we're multiplying what are termed like signs together, such as a positive multiplied by a positive, we know that equals to a positive value. And if we multiply a negative by a negative, that equals a positive value. So for example, 2 multiplied by 6 is 12, and negative 3 multiplied by negative 4 is positive 12. If we're multiplying unlike signs together, so a positive multiplied by a negative, that produces a negative, just as a negative multiplied by a positive produces a negative. So for example, negative 8 multiplied by positive 2 is equal to negative 16, and positive 4 multiplied by negative 4 is also negative 16. The same applies if we're dividing our like signs, so a positive divided by a positive equals a positive, and a negative divided by a negative equals a positive. For example, 6 divided by 2 is positive 3, and negative 6 divided by negative 2 is also positive 3. And finally, if we're dividing unlike signs, so positive divided by a negative produces a negative, negative divided by a positive produces a negative. For example, negative 12 divided by positive 2 produces negative 6, and positive 12 divided by negative 2 is negative 6. I'm just briefly going to review the terms properties and operators associated with our calculations. Sometimes the terms property and operators can actually be conflated, and I have to say I can be accused of conflating the terms. There are actually just slightly different terminologies that can be used, I find. A property of a number is whether it is positive or negative. The operator can be specified as a plus or a minus. So for example, given the sum shown on the right hand side here, we have 3 minus 5 plus 10. The operators in this case are the minus shown here and the plus shown here. If we were to consider the properties of the number as opposed to the operators, then this would be a positive 3 shown here. This would be a negative 5 shown here, and this would be a positive 10 shown here. Just note for reference, in this sum, these numbers here are often termed constants. So 2 of the constants shown, the 3 and the 10, are positive, and the constant 5 is a negative. However, the negative can sometimes be confused with a minus, so sometimes we say that's minus 5, but it's actually negative 5. Something else to always remember about numbers is the sign in front of the number is with that number. For example, the 3, we don't write the positive, but it's positive 3. This is negative 5, this is positive 10. So in other words, think of the sign in front of the constant with that constant or that number. So if I was to reorder this equation, I would put the negative 5 to the front, then I would have positive 3 and my positive 10. So again, you can see these signs stay with the respective constants shown here. So now reading the calculations, the top line I have positive 3 minus 5 plus 10. And on the second line I now have negative 5 plus 3 plus 10. All I'm trying to do here is just highlight the difference between the property and the operator. Where confusion can further arise between properties and operators is when the terminology for the property is stated as plus and minus, which then means the operator needs to be stated as add or subtract, or I sometimes use the term take away when I'm emphasizing the subtraction. So I'm just showing that slide for reference, just to be aware of the terms property and operator. In most instances for us, it really doesn't matter whether we call a number negative 5 or minus 5, but I just felt I should make you aware between the terms of positive and plus and negative and minus, because they actually do relate to different aspects of the calculation. Just for reference, within the calculations we're going to undertake, knowing your times table or your multiplication tables can be quite useful. What we will try and do with the calculations is undertake most of them with mental arithmetic or doing basic hand calculations, and only refer to the calculator as the last result. So let's consider some tutorial questions. We're asked to evaluate the following 6 sums as given to us. What I would encourage you to do is stop the presentation for a moment and attempt these 6 questions. I will work through them in just a moment. So reviewing the questions here, question 1, we've got 3 multiplied by negative 2. I don't really need the bracket there, by the way. I could write that as 3 multiplied by negative 2, means the same thing. So we've got unlike signs here, we've got a positive and a negative, so that will be negative 6. Question 2, I've got negative 1 multiplied by positive 7, so that will be simply negative 7. Third question, I've got negative 2 multiplied by negative 4, so negative multiplied by negative will be a positive, so that's positive 8. Fourth question, 12 divided by negative 4, that could also be written as 12 over negative 4. So when we're dividing unlike signs, we get a negative value, so that will equal to negative 3. 12 divided by negative 4 is negative 3. Question 5, we have negative 8 divided by positive 4. Again, dividing unlike signs, we will get a negative sign, so that becomes negative 2. And finally, negative 6 divided by negative 2, we're dividing like signs, we'll get a positive result there, so that will be positive 3. 6 divided by 2 is 3. Again, this is just for reference. These are called number lines here. The first number line commences at 0, and we move to the right, increments of 1, we get positive 1, positive 2, positive 3, etc. We move to the left, we will get negative 1, negative 2, negative 3, etc. I've also shown a number line below in terms of increments of 10. Whenever we're adding or subtracting, we're actually effectively using a number line, and some students find that helpful to begin with, or when they're adding and subtracting values. So, here's question 1. We're asked to calculate the values of the following expressions, but without using a calculator. So again, I would encourage you to stop the presentation, attempt these little questions here, but I will work through some of them in just a moment. So question 1, we've got 3 added to 4 added to 2. You can clearly see that's going to be 9. Think of that on a number line. We're starting at a number 3 and we're adding 4. So 1, 2, 3, 4. And then we're adding 2. So that's how we get the 9. Question 2, we've got 5 added to 4 and then we're subtracting 11 So that will be negative 2. And again, thinking out on the number line, we're starting at 5, we're adding 4, so that takes us to positive 9, and then we're subtracting 11, so we move from right to left now, and that will take us down to negative 2. Question 3, if you want to use a number line on the previous slide in terms of increments of 10, please do. But basically we've got 40 and we're subtracting 100, so that's negative 60, we're adding 80, so that's positive 20. Question 4, we've got negative 26, add 30, take away 5. So negative 26 add 30 is positive 4, subtract 5, negative 1. Question 5, we've got 12 added to 3 and then subtracting 20. So 12 add 3 is 15 and then subtracting 20, negative 5. Question 6, we've got to be careful of our BODMAS here. We've got a multiplication first of all and then a subtraction. So undertaking the multiplication, 2 multiplied by 6 is 12 and we're subtracting the 5. So that's equal to 7. Question 7, we've got multiplication here and multiplication here, so that's where our precedent lies. So 5 multiplied by 3 is 15, and we're subtracting from that 7 multiplied by 2, which is 14, so that equals to 1. Question 8, we've got negative 2 multiplied by 6 added to 14, so the precedent is here. So negative 2 multiplied by 6 is negative 12, and we're adding 14, so that's equal to positive 2. Question 9, we've got 10 multiplied by 2 added to 3 multiplied by negative 2, so careful, the precedent lies here. So it's equal to 10 multiplied by 2 is 20. Adding to that 3 multiplied by negative 2, that will be negative 6. I'll put it in the bracket. Now we've got the positive and a negative, so positive multiplied by negative there becomes a negative, so that's 20. Subtract 6, that's equal to 14. So finally in question 10 we've got 14, we're taking away from that the negative 8 multiplied by 2 in the bracket, so the precedent lies here. So that will be 40, and we're subtracting from that in the bracket the negative 8 multiplied by 2, so that's negative 16. So that's 40, and we've got this double negative effectively here, so we're adding, in this case, the 16. So that's equal to 56. So we just need to be careful of our signs. A positive multiplied by negative is a negative, and a negative multiplied by negative is a positive. Question 1 continued. This is part 11 through to part 25. Again, I would encourage you to start the presentation and attempt these questions. They all relate to the use of BODMAS. Just be careful with question 23, it does actually involve fractions to find the final answer. The list of answers are shown on the following slide. Question 1, here are the answers for parts 1 through to 25. I will undertake some of the solutions on the following slides. So question 11, notice the precedent here is with the 5 multiplied by 2. So we will get 3 plus 10, 5 times 2 is 10, and that equals to 13. Question 13, again look for precedent. The precedent is with the multiplication here and here. So undertaking the multiplication first, that becomes 35 minus 2 plus 24. Again, referring to table uses there, 7 multiplied by 5 is the 35, and 4 multiplied by 6 is the 24. And evaluating 35, take away 2 is 33, add 24 is 57. Question 15, the precedent lies here with multiplication and here with the division. So we must undertake them first. So 7 multiplied by 5 is 35. And we're subtracting 12 divided by 4, so that's 3, and then we're adding 3. So I can clearly see that's going to be 35. In question 17, the precedent lies here. So again, undertaking a calculation, that's 11 and we're taking away 9 divided by 3 is 3, and we're adding 7. So that's equal to 15. In question 19 we have a bracket now, so we need to evaluate the bracket first of all. So that becomes 3 multiplied by, and 8 add 7 is 15. So that's equal to 45. Question 21, we've got two brackets here that are multiplied together, and one of the brackets is actually squared. So the precedent starts with the brackets first of all. So simplifying them, 2 add 3 is 5, that's 5 squared. And we're multiplying that by 12, subtract the 9, that will be 3. So the next highest precedent is the operations, that's a squared in this case. So we need to evaluate 5 squared, so that's 25, which is still multiplied by 3. So our final answer there will be 75. So in question 23 we've got a bracket divided by 6 and then we're subtracting 4. So we need to apply BODMAS to this problem, but we're also going to apply BODMAS within the bracket itself. And notice that the precedent inside the bracket resides with the 2 multiplied by 10 here. So I could write this as 34 subtract 20 divided by 6, and that's subtract 4. So that's equal to 14 upon 6, subtract 4. It's tricky here, we've got fractions to deal with, so making a common denominator here. The common denominator is 6, think of the 4 divided by 1. 6 divides into 6 once, so 1 times 14 is 14, and 1 divided into 6 6 times, so that's subtract 4 multiplied by 6. So that gives us 14 subtract 24, all divided by 6, which is equal to negative 10 divided by 6, and cancelling top and bottom by 2, that's negative 5 upon 3. That's quite a tricky little sum, that one, bringing in fractions, and we looked at fractions in the previous presentation if you want to review that for reference. Question 25, again a quite complicated question here, so we need to take this very carefully. So I've got a negative and 5 squared, multiplied by negative 2, multiplied by negative 3, and then we subtract the 10. So now be careful here, the negative is outside of the bracket, so only the 5 is squared here. So my first step here will be to square the 5, which will be 25. We're multiplying that by, we've got negative 2 multiplied by negative 3, so that's positive 6, and we're subtracting 10. Now be careful, the precedent lies here with the multiplication. So negative 25 multiplied by 6, that's negative 150, take away 10. So that's equal to negative 160. So question 23 and 25 were quite difficult questions to answer. The solution to question 20 is going to write this on 2 lines. 11 subtract 12 divided by 4, and we're adding to that 3, and that's multiplied by 6 minus 2 in the brackets. That's 3 multiplied by the bracket. Don't forget, if there's no symbol given to us, we always assume multiplication. Some textbooks also show big dots for multiplication, but there's certainly no need for a symbol there. We will assume multiplication. So on the next line, you have 11 minus 12 divided by 4 is 3, and we're adding to that 3 multiplied by, and 6 take away 2 in the bracket is 4, so it's 3 multiplied by 4. So on the next line we'll get 11 subtract 3, that'll give us 8, add to that 12, so final answer 20. Question 22, just going to write this on 2 lines, so that's 15, and we're subtracting from that the 5 squared, subtract the 3 in the bracket, and that's all divided by 11. Evaluating the bracket, we'll get 25, subtract the 3, divided by 11, so that's equal to 15 subtract 22 divided by 11, which is equal to 15 subtract 2, 22 divided by 11 is 2, so the answer is 13. And finally, question 24. I'm going to write this on 2 lines, makes it slightly easier to understand, I think. So the sum is the square root of 4 multiplied by 3 add 37 on the top line, or divided by 86 minus 93 on the bottom line. So evaluating the top line under the square root, that becomes 12 add 37, or divided by 86, and we're subtracting from that 93, so that's negative 7. Evaluate under the square root on the top line, that now becomes the square root of 12 plus 37 will be 49. That's all divided by negative 7. The square root of 49 is 7, so now we've got 7 divided by negative 7. And we can see that's going to be negative 1 as our final answer. 7 divided by negative 7, that's a positive divided by negative, gives us a negative. Finally, some questions for you to undertake. Question 1F here, we've got to find the value of the following. Questions A through to L here, and the answers are shown below. I'd encourage you to stop the presentation and undertake these questions. Question 2F, these are actually true or false type questions. A through to H here. I'll let you decide if they're true or false. Answers are shown below. And finally, question 3F for you to attempt. Hopefully questions A to E will be reasonably okay for you to solve. They're very similar type problems we've looked at already. But questions F through to J have fractions within them, and that causes slight complications. There is a separate presentation on the solution of fractions if you want to review that, and also fractions with the use of BODMAS. Just for your reference, sometimes it does help put in the top and bottom lines in terms of brackets. There effectively are brackets on the top line and brackets on the bottom line, so if that helps you at all in structuring your solutions, you could add in the brackets top and bottom. In all these questions you could put brackets around the numerator and the denominator. That's again just for reference. Here are the answers for question 3F. Here's the bibliography used to help generate the presentation. Some very good engineering maths textbooks. I hope it's been of interest to you, and thank you for viewing.